Hello, ladies and gentlemen. Thank you for watching this video. First of all, I would like to thank the organizing committee of the Latin Geothermal Congress 2025 for accepting my paper and for understanding that I had to present it via video as I was unable to attend the event in person. I will now present the topic Geothermal Power, a giant energy source is still to be tapped in Brazil. Since the oil crisis in the 1970s, Brazilian researchers have been searching for alternative energy sources when geothermal energy potential starts to be excessive. The objective of this work is to identify sites with geothermal gradients above 58 degrees centigrade per kilometer for possible exploitation of geothermal power at depths of not more than 3 kilometers, reaching 150 degrees C. The geothermal data of more than 6,200 wells, with average maximum depths between 200 and 300 meters and maximum depths around 1,000 meters, we consulted and confronted with geological and geotectonic maps and surveys. 40 potentially favorable locations for generation of geothermal electricity have been identified across the country, all with geothermal gradients exceeding 58 degrees Celsius per kilometer, allowing access to high enthalpy resources from a depth of 3 kilometers. In many of them, a heat flow equal to or greater than 200 milliwatts per square meter was also identified, a condition that's favorable to the implementation of a geothermal power plant. Here, on the right, you see the map of Brazil divided into regions: north, northeast, west central, southeast, and south, that identify the various locations here where conditions potentially favorable to the implementation of a geothermal power plant were found. Here we highlighted some of the 40 locations. As in the north, these two regions in the southwest flank of the northern region, here, around here in the map, with geothermal gradients well above 58 degrees Celsius per kilometer and heat flow over 200 milliwatts per square meter. In the northeast region, we selected to present to you these 5 points here, also with geothermal gradients well above 58 degrees Celsius per kilometer. Unfortunately, we don't have the heat flow of these points. And in the west central area, around here, we have these 3 points that are around 71 degrees Celsius per kilometer and one with 81 degrees Celsius per kilometer, and heat flow above 200 milliwatts per square meter here and here, and close to 300 milliwatts per square meter in this point here. Brazil's geothermal potential was assessed by Cardoso, Hamza, and Alfaro in 2010 that identified more than 20 crustal blocks in South America with resources between 1 and 10 gigawatt hours. In this work, we identified an estimated average potential for geothermal power from these 40 points, around 1.5 gigawatts hour of electricity generation. The conditions of these points are related to the Bolivian outflow magmatic activity in the Andes Mountains and intrusive drainage, and also in the northeast zone of the country, Oligocene volcanoes related to the non-lineament that comes out from the Atlantic Mid-Oceanic Ridge, and in the central part of the country, residual stresses from impacting craton and active faulting. To understand the correlation between locations and geology, it's important to first understand the geology of Brazil. Here in the northern region, we have the Paleozoic sedimentary basins of Solimões, Amazonas, and Tapajós, as well as sag basins, intercratonic, pose rift, Paleozoic Mesozoic basins of Acre and Madre de Dios, and the Mesozoic Cenozoic basins of Pará and São Luís do Maranhão. In the northeast region, around here, we have the Paleozoic sedimentary basin of Parnaíba and the Mesozoic Cenozoic rifts of Araripe and Jatobá. From a geothermal point of view, sedimentary basins may have some potential for generating heat and thermal waters without producing electricity, that is, low to medium enthalpy potential. Also in the northeast, you have part of the stable craton of San Francisco. In the central-west portion, around here, we have the northern part of Paleozoic sedimentary basin of Paraná, with a thickness of 8,000 meters of sediments and collate intertap basalts that are home of several thermal springs, including those with the highest surface temperatures, which are predominantly used for bathing, recreation, and tourism. To the west of the sedimentary basin of Paraná, we have the Cenozoic sag sedimentary basin of Pantanal. The rest of the map, the dark green area here, is represented by, in the northern part, Precambrian Amazonian orogenic fold belts, in this region here, the northern region, this gray area here, okay? And mobile folded belts around all this area here that are represented by metasediments of various facies and synthetic and anesthetic, mafic, intermediate, and acidic intrusive bodies that extend from the northeast region to the southeast region of Brazil. This map, which is structurally more detailed and contains more information than the previous one, produced more than 20 years after the previous one, highlights the structures and relationships between cratons and mobily folded belts, as you may see here, and also basins, okay, here and here, for instance. Lignous bodies and structures resulting from tectonic evolution are the points where potential sites for geothermal power generation are located with high values of geothermal gradients. Therefore, although not highlighted here, in the northeast region, the influence of a lineament that extends from the oceanic the Atlantic mid-oceanic ridge through Fernando de Noronha, in a lineament that comes here to the northeast region, associated with some recent low activity faulting, may be related to the high geothermal gradients found here. In the northern region, in the southwest flank, the influence may be related to the Bolivian highlands of the Andean mountains that are around here, out of this map, and granitic bodies that are in this area. Meanwhile, in the central zone here of the country, large structures that comes out all this way here, this mobile folded belt, this Brazilian orogenic belt here, okay, associated with the impact of continents in the past, within zones of high residual stresses, appear to be the cause of the anomalous geothermal gradients in this area. In conclusion, it can be said that Brazil does not have traditional geothermal power fields. However, Brazil has promising resources for exploitation of high enthalpy and medium enthalpy fields for geothermal power. At least 4 sites were identified for further research. The technology to be used is that of the binary cycle systems, Rankine or Kalina cycle, and injection purging wells of an EGS HDR system or an AGS-ACL system technology. The investment need to achieve this goal is the completion of data from existing wells and field work, geophysics, implementation of exploratory well, and then the development of the project. In terms of research, we are estimating a $30 million budget to achieve this goal. Details of this work you may find in this publication in the Energy and Power Engineering magazine, number 17, pages 71 to 106, that can be found in this link here, okay? And also, I suggest you try to find this paper here that unfortunately is in Portuguese but can be easily translated with any translator in the internet. That's about the geothermal power generation from Kalina type of plants. That was written by a student of graduation of mine in 2010. So please, if you may, take a look on this information. Once again, I want to thank the organizer of LGC 2025 for accepting this presentation, make it possible to present it remotely. Also, if you have any questions related to this publication, to this presentation, please feel free to contact me in this email here, okay? And I'll be pleased to answer any questions you have. Thank you very much for your attention, time, and patience. All the best for you all. Bye-bye.